Hey guys, today I thought we'd do something a little bit different for you here on YouTube. I thought we would do some immunity multiple choice questions together. Now, this is great if you're doing OCR biology because obviously you have multiple choice questions on your first two papers, but this is also great if you're doing AQA. You will get one or two multiple choice questions, and they're really good to practice just to check your knowledge and your AO1 recall is solid. So let's go through them together and see how many you can get right. First question, a person is bitten by a venomous snake. The immediate treatment is normally to inject the person with antibodies. What type of immunity is this? So it's an injection, so that is artificial. So it's going to be A or B. We can eliminate these two straight away because an injection is obviously artificial. And you're injecting them with antibodies. They're not making the antibodies themselves with their own plasma cells, and it's not going to lead to the production of memory cells. So it's going to be passive. It's going to be short term. So the correct answer for that one was B. Let's have a look at this maths question, hopefully not too difficult. The chart shows the number of reported cases of malaria between 1995 and 2000 in South Africa. Which of the following answers is the percentage increase from the number of cases in 1995 to 2000? So we're going to read off the data carefully. So in 1995, there were 10,000 cases. And in the year 2000, if we get our ruler and we do a straight line across, there were 65,000 cases. Now, percentage change is obviously the difference over the original, or the change over the original, times 100. So to find out the difference, we're going to subtract 10,000 from 65,000, which gives us a difference of 55,000, or a change. It's increased by 55,000 cases, divided by the original, which in this case is the number of cases in 1995, because that came first. Then we're going to times it by 100, and you should get the correct answer of B, 550%. And use a bit of common sense. I mean, it's massively gone up. If it had doubled, it would be a 100% increase, but it's actually increased over 5 times. Looks about right. So 550% seems like a sensible answer. Question 3, which statement A to D correctly describes a process that provides artificial, not natural, active immunity? So we're looking for a type of immunity that is not natural, so you haven't just caught the infection yourself. It's active, so it is going to stimulate the immune system. It is going to lead to the production of plasma cells and antibodies and memory cells. A, well, that's just an injection of antibodies, so that would be artificial and passive. C, antibodies provided from milk. Well, milk is natural, but again, you're just giving the antibodies, so that would be passive. Antigens received on flu viruses via water droplets in the air. Well, that would be natural active. You are going to stimulate your immune system if you get those antigens in your body, but it's just being spread via water droplets in the air. That's natural. You're actually getting the disease naturally. So the only one that's artificial and would lead to an active response would be B. You're being given the antigens, but you're not catching the disease. You're being given the antigens in a type of immunization. The polio antigens are being given in a sugar cube. I remember I had that when I was younger. I don't think it's done anymore, probably because sugar's bad for you. But yeah, you're being given the antigens, so it's artificial. But it will stimulate your immune response. It will stimulate your plasma cells to make antibodies and to form memory B cells and memory T cells. So it will give you long-term active immunity. So B was the correct answer there. Which of the following human diseases is caused by a fungus? Right, let's do process of elimination. TB is caused by a bacteria. Malaria is obviously caused by the malarial protist, which is spread by mosquitoes as the vector. Influenza or the flu is caused by a virus, but this one is caused by a fungus, which you should have known from GCSE, to be honest. So yeah, the answer there was A. An individual bitten by a rabid dog can be treated by an injection of human rabies antibodies. Which option describes the type of immunity? We should be really confident with these now. We've done about 3 already. It's an injection. That's clearly artificial. It's not natural. They're just injecting antibodies, so the immune system is not making them for themselves, and they will therefore not produce memory cells. They will therefore not have long-term immunity. This is just fast-acting, short-term immunity. So it's artificial and it is passive. So the correct answer there was C. Okay, we've got an antibody. Which part of the antibody is an antigen binding site found at? The correct answer here is going to be A. And I know it's A because at the top of the antibody here, we have what's known as the variable region, which is different from one antibody to the next. It has a different tertiary structure. That's where we find the antigen binding site. Each antibody has a different antigen binding site with a different tertiary structure, so it's complementary to a specific antigen, and the antigen combined in that region forming the antibody antigen complex. Obviously, there is another one here as well. So each antibody can bind to two antigens simultaneously, which helps the antibodies to clump the pathogens together or cause what we call agglutination. Let's do a few more. Oh, another one like this. I think I said on TikTok I was going to help you with these questions, so I've put lots of these style of multiple choice question in. Autoimmune diseases, so diseases where the patient's own immune system is destroying their own tissues, they're often treated with a course of antibody injections. Which of the following statements describes the immunity arising from this treatment? Easy peasy, it's an injection, it's artificial, they're giving you the antibodies. So it's going to be D. It's passive because they're just giving you the antibodies, you're not making them yourself. Artificial because it's an injection. So yeah, the answer there is D. Let's have a look at another couple. The primary immune response, so the first time your immune system encounters that foreign antigen, it involves differentiation, clonal expansion of certain white blood cells. Clonal expansion, by the way, just means that the cells will clone by mitosis. You don't have to use the word clonal expansion if you're AQA, but they clone by mitosis and then they'll differentiate into different cell types. Which of the following cells result from clonal expansion during a primary immune response? Well, B lymphocytes are activated, they undergo clonal expansion and they can differentiate into plasma cells, and they can also differentiate into memory B cells. But also T lymphocytes are activated, they can differentiate into killer T cells or cytotoxic T cells, and helper T cells and memory T cells. So even though it would be quite a slow response and it would take some time, all of these three types of cell would result from clonal expansion during a primary immune response. Convalescent plasma immunity is one method used to treat patients infected with the Ebola virus. In this method, blood plasma is taken from a person who has recovered from the Ebola virus and it is injected into the patient. This is a little bit of a harder question, I feel. I mean, straight away we can see it's an injection. So it's going to be artificial, right? So we can cross off C and D. If you're taking blood plasma from a person who has recently recovered, in their blood plasma, there is going to be antibodies and memory cells. But if you inject that into the patient with the infection, they are not making those antibodies themselves. They're receiving those antibodies from someone else's blood plasma. So it's artificial and it's passive because the patient's own immune system is not making the antibodies. They are coming from someone else who has produced them when they were infected. So it's artificial and it's passive. So it's not actually going to stimulate the production of memory cells in the new patient, but it is going to help them by increasing the concentration of antibodies in their blood. It's going to help them to destroy the pathogens more quickly, or the virus in this case. Last question that we're going to do together. Which row, A to D, correctly identifies the parts of the antibody structure? Let's start with P then. So P, which we can see here on the diagram, this is what we call the antigen binding site. It has a tertiary structure that will be complementary to a specific antigen. The antigen can bind there, and obviously there's another one over here as well. So we've limited it now. We know it's going to be B or it's going to be D. If we look at Q, Q here is the variable region. It's the sequence of amino acids that will be different for different antibodies. The tertiary structure will be different, and that's what gives rise to these different antigen binding sites with different tertiary structures. So the variable region, we've not limited it down anymore, have we? It's still going to be B or D. R here, this is the part of the antibody that is the same for all antibodies with the same tertiary structure. So that's going to be the constant region. We still haven't got our final answer. S is pointing to this chain here, which is a shorter polypeptide chain. So S is a light chain, whereas T is a heavy chain because it's a longer polypeptide chain. So I think we've now got our answer. It's got to be D. Remember, antibodies have a quaternary structure. They do consist of 4 polypeptide chains, 2 heavy or longer chains, 2 shorter or light chains. They are held together by disulfide bonds, which are strong covalent bonds. There's also what we call a hinge region here, which allows the antibody to have some flexibility, which is helpful because it means those 2 antigen binding sites can bind to 2 antigens on 2 different pathogens, because the antibody can flex in order to allow the antibody to do that due to that hinge region in the middle. That's our last question for today. Let me know in the comments if you enjoyed that, if you found it useful, and how many questions you were able to get right.